In this class we will just look at functions of matrices, and we will just start with the exponential of a matrix. All right. So, suppose A is an n cross n matrix, matrix. So, what is e power a? The exponential of a matrix. So, generally, I mean, if you have, suppose x is a variable, and e power x, if x is a number, then you can say that 1 plus x square by 2 factorial, this is expansion of e power x, right, plus etc. etc. Okay. So, that will be the case. Now, in the case of exponential of a matrix, similarly you can define it. So, you have I, this is an n cross n matrix, I n cross n plus a plus a into a divided by 2 factorial plus a divided by 3 factorial plus etc. etc. Okay. So, as an infinite series you can define this is the exponential of a matrix A, e power a. And here this is an n cross n matrix. So, A is already an n cross n matrix. So, this A square also will be an n cross n matrix. So, basically e power a is going to be another, it's an n cross n matrix. Okay. All right. So, let us just try to evaluate the exponential of a matrix okay. So, and then we will generalize it. So, we will take a particular matrix and then we will generalize, do a general formula for that. Okay. So, suppose that I need to find e raised to I sigma 2 theta, okay, where sigma 2 is the polymatrix 0 minus I 0. Okay. In the last class we discussed about and so you can see that, I mean, what is sigma 2 square? Okay, in the assignment in the tutorial session we will describe the properties of the polymatrices. So, then we will okay. So, what is sigma 2 square is again, so it will be I 2, it will be identity. You can see that you take the product of sigma 2 into sigma 2, you will see that it is going to be identity matrix. Okay. So, e raised to I sigma 2, where theta is some parameter, and you have I sigma 2 theta. Okay. So, e raised to I sigma 2 theta by definition, which is equal to identity plus I sigma 2 theta plus I sigma 2 theta whole square divided by 2 factorial plus I sigma 2 theta whole cube by 3 factorial plus I sigma 2 theta raised to 5 divided by 4 divided by 4 factorial plus etc. etc. Okay. All right. So, this is equal to I plus I sigma 2 theta, and I square is minus, right, minus sigma 2 square is identity. So, minus theta square divided by 2 factorial, okay, into identity plus here you have I cube will be minus I. So, minus I sigma 2 cube will be sigma 2, because sigma 2 square is identity. So, sigma 2 cube will be sigma 2 divided by 3 factorial sigma 2 into theta cube divided by 3 factorial plus I raised to 4 will be 1 and sigma 2 raised to 4 will be identity. So, theta raised to 4 divided by 4 factorial into identity plus etc. 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 All right. So, this is equal to, and now we will have two types of this thing, the terms which will have identity matrix, and then we will have terms which will have sigma 2. Okay. So, I can write identity into 1 is a minus the second type theta square divided by 2 factorial, and then you have theta raised to 4 divided by 4 factorial minus plus I sigma 2 into theta, then minus theta cube divided by 3 factorial plus etc. etc. Okay. So, e raised to I sigma 2 theta, which is going to be equal to, what is this thing? This is cos theta. So, I2 basically, I2 cos theta plus I sigma 2 and I sigma 2, and this is going to be sin theta. Okay. All right. So, this is what? This will be cos theta 0 0 plus I into 0 minus I 0. So, I square it will be equal to 1, minus I square will be 1 and this will be minus 1. So, into sin theta will be sin theta minus sin theta. Okay. Or this is equal to cos theta minus sin theta minus sin theta cos theta, or basically this is r theta, the rotation, right, in the xy plane. So, this is the cos theta, this is a rotation matrix basically, right. So, e raised to I sigma 2 theta is nothing but this. Okay. So, you can see that, I mean, it is an exponential of a matrix, and see how it is again, as we said, it is a 2 cross 2 matrix, and it is a very familiar matrix for you. Okay. Now, given an arbitrary, I mean, similarly you can generalize it to I sigma dot n theta. Okay. So, we will discuss this in the tutorial session. Okay. So, okay, fine. Now, given, suppose that you have a matrix and suppose that you have a matrix A, okay, and let this matrix be a diagonalizable matrix. That means A is a normal matrix. If A commutes with A dagger, that is if A is equal to A dagger is equal to 0, then you say that it is a normal matrix, and normal matrices are diagonalizable in principle, and this can be diagonalized by a similarity transformation. That means you can say lambda, which is equal to S inverse AS. By doing a similarity transformation, you will be able to get a diagonal matrix. Okay. So, this is okay. So, all right. So, now you need to, so if lambda is equal to S inverse AS, then what is A? A is if you multiply S from the left hand side, so you will get S lambda, and if you multiply from S here, S into S inverse will be identity, and then S lambda S inverse, this will be your A. If A is lambda is S inverse AS, then A will be equal to S lambda S inverse. Okay. And now I need to evaluate e raised to A. Okay. So, to evaluate e raised to A, I know what is, this is identity plus A square divided by 2 factorial, or A into A divided by 2 factorial plus A cube A into A divided by 3 factorial plus etc. etc. Okay. So, instead of A, I can substitute for S lambda S inverse, where okay, this lambda is a diagonal matrix. You know what is when you diagonalize the matrix, you will get lambda 1, lambda 2, lambda 3. The eigenvalues at the as the diagonal elements, and all other elements will be 0. That is what you get when you diagonalize a matrix, you will get it like this. Okay. So, this is equal to identity plus A instead of A, I can write S lambda S inverse plus this A S lambda S inverse into S lambda S inverse divided by 2 factorial plus S lambda S inverse S lambda S inverse S lambda S inverse divided by 3 factorial plus etc. Okay. And similarly, I can write identity as e raised to A, identity as S inverse. Okay. S inverse. So, instead of I can write S inverse. So, I will take S from the left hand side, S out from the left hand side. So, you will get an S inverse from the right. So, what will you get? So, you will have 1 or identity there, identity plus lambda plus here you can see that this will become identity. So, S into lambda square S inverse. So, you will have a lambda plus lambda square. In the next term, this will be identity and this will be identity. So, lambda cube by 3 factorial plus etc., etc. Or this is equal to S into e raised to lambda S inverse. Okay. And this will be e power a. Now, what now you look at what is e power lambda, what is lambda? Lambda is a diagonal matrix, say for example lambda 1, for example let us just take the case of a 2 cross 2 matrix. So, lambda 2, you have 2 eigenvalues, that will be lambda 1 and lambda 2 here. If it is a 3 cross 3 matrix, you will have lambda 1 0 0 0, lambda 2 0 0 0, lambda 3, that will be the case. Okay. So, if you want to write e raised to lambda, okay, so you will have identity plus lambda, lambda is this matrix, lambda 1 0 0 lambda 2, okay, plus lambda square. So, this square is going to be equal to 1 by 2 factorial into lambda square, right. So, this is going to be, if you take a diagonal matrix, this diagonal matrix and square it, you will get lambda 1 square 0 0 lambda 2 square plus if you 1 by 3 factorial lambda cube, this lambda cube will be, you will get lambda 1 cube 0 0 lambda 2 cube plus etc. So, e raised to lambda, you get it as identity plus okay. So, identity is what? 1 0 0 1, right, plus this quantity. So, you will get 1 plus lambda 1 plus lambda 1 square divided by 2 factorial plus etc., 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 0 0 1 plus lambda 2 plus lambda 2 square by 2 factorial plus etc., etc. And what do you get from here? You will get e raised to lambda is nothing but e raised to lambda 1 0 0 e raised to lambda 2. Okay. So, if you take a diagonal matrix and exponentiate it, so it will be the just exponential of the diagonal elements. E raised to lambda is equal to e raised to lambda. If it is a 3 cross 3 matrix, you will have diagonal e raised to lambda 1, e raised to lambda 2, e raised to lambda 3, all other elements will be 0. Okay. All right. So, to calculate e raised to a, you can easily, if you know the eigenvectors, you will be able to easily construct e raised to lambda. Once you know lambda from the eigenvectors, you will be able to construct the matrix S. So, once you know the eigenvalues and eigenvectors, you can easily compute eigenvalues and eigenvectors of the matrix A. You can easily compute the exponential of the matrix A, like this, S into e raised to lambda S inverse. S is a matrix which consists of the eigenvectors. I mean, you know how to diagonalize what is the S matrix and all, like from your degree classes. Okay. So, now let us evaluate determinant of exponential of A. Okay. And determinant of exponential of A is going to be equal to the determinant of S into e raised to lambda S inverse. Okay. So, this is equal to, I mean, you know, determinant of the product of matrices will be determinant of S into determinant of e raised to lambda into determinant of okay. So, I mean, you do not need to do that, you can just try to, I mean, sorry, you can write this as determinant of determinant of S into determinant of e raised to lambda into determinant of S inverse, and determinant of S into determinant of S inverse is going to be identity. So, it will be determinant of exponential of lambda, and you know already you know that e raised to lambda is e raised to lambda 1 into e raised to lambda 2, e raised to lambda 3, etc. So, determinant of e raised to lambda will be determinant of e raised to lambda will be e raised to lambda 1 into e raised to lambda 2 into e raised to lambda, etc., etc. So, it will be e raised to lambda 1 plus lambda 2 plus, etc., etc. So, the sum of the eigenvalues is actually equal to the trace of the matrix. So, you can write this is equal to determinant of the exponential of trace of A. So, this is the determinant of exponential of A. So, I can write determinant of exponential of A, which is equal to exponential of trace of A, Okay. Here I again determinant of exponential of lambda is going to be equal to e raised to trace of A, because the sum of the eigenvalues is equal to the trace of the matrix. Okay. So, again I will do a few examples of 1 or 2 examples in the tutorial session for this one. All right. And similarly, I mean you can define the log of a matrix, the cos of a matrix, the sine of a matrix, etc., etc. Okay. So, that we will do in the next class.